My name is Paige LaMore, and I'm a graduate student in the lab of Dr. Rob Woods here at the University of Georgia. I'm involved in GlycoMIP projects that utilize an optical analytical technique called biolayer interferometry, or BLI. The basis of BLI is its ability to detect the binding of a molecule in solution to another molecule that has been immobilized to a sensor surface. Here at the CCRC, we have the Octet384 system from Sartorius. This instrument utilizes a glass biosensor in which a protein or glycan can be immobilized to either by antibody-specific capture, affinity tag capture, or chemical coupling. This instrument can pick up 16 biosensors per an experiment, and it dips it into a molecule in solution that is contained in this 384 well plate format. Essentially, this instrument shines a white light through the biosensor in which it's able to measure a change in wavelength response. While BLI is a robust method, it is specifically useful for measuring binding affinities, kinetics, and glycan protein concentrations. Additionally, it is useful for inhibition assays to identify lead compounds for drug discovery projects. Over here, I will give an example of how this data can be processed. This is an example of a spike from SARS-CoV-2 binding to ACE2 wild type. On the y-axis here, you see how it measures the wavelength response in nanometers, and on the x-axis, it shows how the change in wavelength is measured in time, in seconds. As you can see, you can measure a K-on value, or a rate of association, as well as a K-off value, or a rate of dissociation, to generate a binding curve or saturation curve in which a Kd value can be measured for.
Hello, my name is Lauren Pepi, and I'm a postdoc here at the CCRC. I'm standing in front of our newest LCMS system, and this was funded thanks to GlycoMIP. The LC portion of this is an RS-LC nano-LC system, and so this uses very small injection volumes to get a lot of information out of, and this helps us to conserve sample. This has an auto sampler, so we can do automated injection and look at many samples back to back. This is coupled to our Thermo Fisher Orbitrap Eclipse tribrid mass spectrometer. This is the newest in the tribrid series, and it has faster scan times, higher resolution, and higher sensitivity than the previous models. With this increase in sensitivity, we're able to get informative information from just 0.1 micrograms of a glycopolymer sample. We can also get an accurate mass for a sample up to 4 decimal places, thanks to the fact that this is a Fourier transform mass spectrometer and it has extremely high resolution. And in addition to just getting an accurate mass, we can also do what's known as tandem mass spectrometry, which takes a compound and breaks it up into its individual building blocks. And that way we can really get a confident structure from that. So we have 3 different tandem mass spectrometry techniques that we can use with this instrument. Collision-induced dissociation and higher energy collision-induced dissociation are both what is known as vibrational excitation techniques. And these use an inert gas. In our case, we use helium. And the helium ions will collide with our compound, resulting in it to fragment. We can also do what's known as electron transfer dissociation, which is an electronic excitation technique. And this uses an electron acceptor to strip an electron from your analyte, and this will result in fragmentation as well. With electron transfer dissociation, we can get a higher level of fragmentation, and we can really figure out the exact structure, even of the most difficult glycopolymer. And so to any experiment, we can also add what's known as FAMES, and FAMES stands for High Field Asymmetric Waveform Ion Mobility Mass Spectrometry. And FAMES uses ion mobility characteristics to funnel compounds based on their unique properties. So we can add FAMES to any experiment, including an LCMS experiment. And when we do that, we are able to get 2 different levels of separation, first on the LC end and then on the ion mobility end. And this would help us to characterize even the most complex glycopolymer mixture.